In the last video, we talked about augmented matrices, and the most of the material in this video will be from section 1. An augmented matrix comes from the coefficients and the constants of a system of equations. And so the goal in using matrices is to solve systems. To take a system, first we would write a system as an augmented matrix and then perform matrix row operations. And then finally, we would come down to a reduced echelon form. And so basically what it would look like would be something like this. So first you have a system of equations, and then we would write it into an augmented matrix. And then we would perform row operations, which we'll talk about in a few minutes. And eventually with those row operations, we would rewrite our system to look like this, where you have 1 in the diagonals and zeros everywhere else. And from there, we can get our solutions for x and y by rewriting this into a system of equations. So you might be wondering, why can't I just use what we learned in chapter 7, which was solving the system using substitution or addition? And this is just another way that is used to solve these systems. Once we get into systems that are larger than 3 equations, then matrices might be a more convenient way of doing it, especially if you have technology to help with solving the systems. So if we look at the next example, so what are these row operations that we can use? So the first row operation is interchanging any 2 rows. Okay, so for example, if I had a system, I can rewrite it as this way instead of this one. So I just interchange the 2 rows, doesn't change the system. I can multiply by a non-zero constant, and that is I can multiply a row by a non-zero constant. And so if you remember when we were solving these equations, if we wanted to, let's say we had a 2 here and we wanted to cancel the x's, then we multiplied this whole row by -2. And so that is similar to what we'll be doing with the matrices. And then number 3, we can add two rows together. Okay. So 2 matrices are row equivalent if one can be obtained from the other by a sequence of row operations. So again, the process to arriving to our goal, which is to solve for x and y, is going to be taken using these steps here, where we have your system, you write it as augmented matrix, use row operations, and then we end up with a reduced echelon form. So the symbols that we use for these operations are the following. If you see this symbol here, R1, double arrow R2, this just means switch row 1 with row 2. If we see CR2 with 1 arrow pointing to R2, this means multiply row 2 by C and place results in row 2. If we have R1 plus R2, then this would be add rows 1 and 2 and place results in row 2. Okay, so let's use this matrix here as an example. So we're going to use this matrix for each of these A, B, and C. Okay, So for row 1, for example 2a, row 1, switch with row 2. So our result, this is our original matrix. And so our result would be, and this is how we write it, row 1 with row 2. So I'm going to take row 2 and write it first because I'm switching it with row 1. And then row 1 becomes row 2. And row 3 stays the same. Okay. So for letter B, we have 1/4 times R1, and then our result would be placed in R1. So let me go ahead and write it down here. So 1/4 R1, place in R1. So I'm going to have 1/4 times, actually, let me just write the matrix first, row 1. Okay. And so we want to multiply 1/4 row 1 and place the results back in row 1. So here's my row 1, and I'm going to multiply that times 1/4. So 1/4 times 4 is going to be a 1. 1/4 times 12 would be a 3. 1/4 times -20 would be -5. 1/4 times 8 would be 2. And then the rest of the matrix will remain the same as we didn't multiply those rows by any other number. So let's look at letter C. Here we have row 2. So let me just write the matrix. One, 6, -3, and 7. -3, -2, 1, -9. And we want to multiply by row 2, add it to row 3, and then place back in row 2. So I ran out of space here, but I would normally put the matrix right here. So I'm just going to put it down here. So here, the only row that's going to change is row 2. So row 1 is going to remain the same. And row 2, although we're using it, at the end, the only thing that is going to change is row 2. So let me go ahead and scratch that out really quick. So row 3 is what I meant to say is not going to change. We're using it, but we're not going to change it. So the only thing that's going to change is what goes in here for row 2. So first we would multiply row 2 by 3. So I'm going to multiply it here. So that would be 3 times 1 is 3. And then the result we're adding to row 3. So 3 times 1 is 3 plus -3 is 0. And then -3 times 6 is 18 plus a -2 would be 16. And then 3 times -3 is -9, and we're adding it to row 3, so then we get -8. And 3 times 7 is 21 plus -9, and so that gives us a positive 12. Okay, so notice here we multiplied the second row by 3, and the results we were adding to row 3, but at the end, the final result is we've placed for row 2. Okay, so the process that we're going to be using to solve the system using matrix operations is called Gauss elimination. Okay, so for example, here it says use a matrix to solve the system. So before I use this example, let me go ahead and we can start with the example we had before. Let me just get a piece of paper. So let me work out the previous one first. And this is the one that I'm talking about. So x plus y equals 4, x minus y equals 2. So the instructions are solve the system using matrices. So first we need to write this system into a augmented matrix. Okay, so always remember your goal is to make this matrix look like this matrix where you have one in the diagonals and then zeros everywhere else. Okay, so first, our first goal is to make this a 1. And so if you notice here, we already have a 1, so we don't have to do anything. Then you're going to use this one to make everything below it a 0. You could make this a 1 first, but it might make you work in circles. So the best thing would be to use this diagonal to make everything below it a 0, and then you work with the second diagonal. Okay, so in order to make this a 0, I need to make sure that when I add the two rows, it's going to be a 0. So what we can do is we can multiply row 1 by a -1 added to row 2, and then place our results in row 2. Here, what we're changing is row 2. So I'm not going to change row 1, so I'm just going to write it down. And so now I can multiply this row 1 by -1. -1 times 1 is -1, plus 1 gives me a 0. -1 times 1 is -1, plus a -1 gives me a -2. And -1 times 4 is -4, plus 2 is -2. Okay, so now your next goal is to make this diagonal 1. So in order to make this diagonal 1, I would have to multiply row 2. I'm going to multiply it by a -1/2 times row 2 and place my answer back in row 2. So here I'm not changing row 1, so I'm going to write row 1. And now for row 2, I'm going to multiply by -1/2 times 0 is 0. -1/2 times -2 is +1. And -1/2 times -2 is +1. Okay, so now I have my 1. So now we're going to use this one to make everything above it and below it 0. In this case, we only have stuff above it, so I need to make this a 0. So I'm going to go ahead and just come down here so we can have more space. So my matrix was 1, 1, 4, 0, 1, 1. So I'm going to multiply -1 times row 2. I'm going to add it to row 1, and I'm trying to change row 1, so I'm going to put my solution back into row 1. I'm not going to change row 2, so I just place it down or write it down. And so now I'm going to multiply -1 times 0 is 0, plus 1 is 1. -1 times 1 is -1, plus 1 is 0. And -1 times 1 is -1, plus 4 is 3. So now, if you notice, we have reached our goal where we just have ones in the diagonal and zeros everywhere else. And so from here, since I'm working with x and y, then the first number here represents x. So x is equal to 3 and y is equal to 1. And so this is our solution to the system. Okay, so let's try one more. So first we write down the augmented matrix 2, 4, 8, 1, -1, and 5. Then we use row operations. So here I need a 2 to be a 1. So you can multiply by 1/2, but notice below it's already a 1. So I'm just going to switch the rows. So I'm going to switch row 2 with row 1. So 1, -1, 5, 2, 4, and 8. Now I'm going to use this one to make everything below it a 0. So I'm going to multiply by -2 times row 1, add it to row 2, and then I'm going to put the results in row 2. I'm not changing row 1, so I'm just going to write it down. So if I multiply by -2, -2 times 1 is -2 plus 2 is 0. -2 times -1 is +2 plus 4 is 6. And -2 times 5 is -10 plus 8 is -2. Now I want to make the 6 a 1, so I'm going to multiply by 1/6 times row 2 and place my results back in row 2. So the first row I'm not changing, and I'm multiplying this by 1/6 times 0 is 0, 1/6 times 6 is 1, and 1/6 times -2 is -1/3. Okay, and then the next one, let me just copy down the matrix. So here we would have, we want to use this 1 to make that a 0. Notice that this is already negative and this is already positive. So I'm just going to add row 1 plus row 2, and I'm going to put it in row 1 because I'm trying to change row 1, so row 2 will stay the same. 0 plus 1 is 1, 1 plus -1 is 0, and -1/3 plus 5. We need a common denominator of 3, so that's going to be 14/3. So my answer here is x is 14/3 and y is -1/3. So I'm going to show you how to put this on your calculator. For any matrix greater than 2, you can use your calculator. And so let me go ahead and enter it for this example. And then bring up the calculator. So to do this, first you want to go second matrix. So second matrix. You can choose any matrix or use the same ones you have there. I'm going to use A. And you want to enter the size of the augmented matrix. So this is a 2 by 3 because we have 2 rows and 3 columns. And so I'm going to put 2 by 3. I'm going to enter the numbers. So I have 1, 1, and 4. Then I have 1, -1, and 2. Once your matrix is in there, you can just second quit and then go back second matrix. And we're going to do some math with it. So you want to go all the way down. And you want to use the key that says RREF. So I'm going to press enter. That just means reduce row echelon form. So I press enter, and now we need to call the matrix. So second matrix. I want to use A, so I press enter, and then I press enter. And so if you notice here, we get our result, which is the same as this. And then we just need to interpret it as x equals 3, y equals 1. Okay, so let's go ahead and enter the previous one we did. So let me go second quit. I'm going to do second matrix. And I usually just stick with letter A, and I just change it there. So in this one, it's a 2 by 3 as well. And my numbers are 2. So I'm looking right here. So 2, 4, 8, 1. Actually, let me go back. 1, -1, and 5. Okay, so I'm going to go second quit. Second matrix, I'm going to use math. Go all the way down to letter B. Call the matrix. enter. And so we get some decimals here, which is okay. If you don't want the decimals, then we can say go to math, and you see number 1, we can press enter, and it will change it to fractions. So we have 14/3 and 1/3, which is what we got here. Okay, so let's do example number 4 using the matrices. So here, you want to write down your augmented matrix to have a better view of what we'll enter in the calculator. Okay, and then our final goal would be 1, 0, 0, 0, 1, 0, 0, 0, 1. And that's what we're going to get from the calculator. So second matrix, going to edit. This is a 3 rows by 4 columns. So 3 by 4. And I'm going to enter the numbers. So 2, 1, 2, and 18. Then we have 1, -1, 2, and 9. And 1, 2, and -1, and 6. So second quit, second matrix, we're going to do math. Go to the bottom, call your matrix. Always remember where you put the matrix so that you don't make a mistake. I think that's why I always use A. So here we get 5, 2, and 3. So my solution here is x is equal to 5, y is equal to 2, and z is equal to 3. So 5, 2, and 3. And then the last one, same thing, we just write down our augmented matrix. Again, you don't have to use a calculator. You can use this process that we did up here. I encourage you to try it after you use your calculator. That way you can see the process. So second matrix, this is still going to be 3 rows and 4 columns. And I'm going to change the numbers. So we have 3, 1, 2, and 31. Then we have 1, 1, 2, and 19. And then we have 1, 3, 2, and 25. So we're going to do second matrix, math, or REF. Oops. Make sure you exit out first. Okay, so second quit, second matrix, math, and call the matrix. So we get A. And so our answer is 6, 3, and 5. So my solution system here is 6, 3, and 5. So that's your X, Y, and Z.